Bismillahirrahmanirrahim. Today I am going to discuss bonding in electron deficient molecules, 3-centered 2-electron bonding and back bonding. And in the last I will discuss 4-electron 3-centered bond or 3-centered 4-electron bond. Let's start with the electron deficient atoms, which usually belongs to second and third group of the periodic table, and specifically those atoms which form covalent bond. So if we take the example of boron, its electronic configuration in ground state is this, and in excited state this electron from 2s jumps to the vacant 2p orbital. So it has 3 unpaired electron in its outermost shell. So after utilizing all of 3 electron, for example, by sharing mutually with hydrogen, boron acquire 6 electronic state in BH3, which is not enough to give it to stability. So how it removes electron deficiency? Let's explain this. So 4 of its orbital 1 vacant, these undergo sp3 hybridization. If we see this boron, it undergo sp3 hybridization, and there are 4 of its orbital sp3, 1 vacant. If we see the other boron atom, it also undergo sp3 hybridization, and this is vacant sp3 hybridized orbital of this boron. If we see this overlap, so sp3 orbital of boron overlaps with 1s orbital of the hydrogen, and simple covalent bond is formed. And if we see this sp3 hybridized orbital, it also overlaps with 1s of hydrogen, another simple covalent bond is formed, and similarly this sp3 overlap with 1s of hydrogen and this. So 4 simple covalent bonds are formed by both boron atoms. If we see this partially filled sp3 and this vacant, these commonly overlap with 1s orbital of hydrogen. Similarly, this vacant and this partially filled sp3 hybridized orbital of boron, they commonly overlap with 1s orbital of the hydrogen. So hydrogen here is acting as bridging atom. So as a result of this overlap, we obtain this type of bond, banana-like. So in this overlapped structure, or in this bond, hydrogen is present in the center, which is acting as a bridge, and there are 2 electrons between these 3 centered. Similarly, this bond is also called as 3-centered 2-electron bond. Boron, hydrogen and boron, these are 3-centered, and there are 2 electrons, so this bond is called as 3-centered 2-electron bond. If we see this boron, it has 4 electron in outermost shell. Let's count: 2, 2, 4, 2, 6 and 2, 8. Similarly, this boron also acquire an octet state. So by dimerization, as in B2H6, boron fulfill its electron deficiency or remove its electron deficiency. But in BF3, the vacant orbital present on boron, it form a pi bond with the attached fluorine. So this is called as back bonding. So BF3 remove its electron deficiency and get stabilized by this type of bond. This is a kind of parallel overlap between vacant sp3 orbital and filled p orbital of the fluorine atom. This is called as back bonding. If we see the structure of Al2Cl6, how aluminium remove its electron deficiency? This is the electronic configuration of aluminum in ground state, and this is in excited state. Similarly, it also undergo sp3 hybridization. So these are 4 orbitals as shown in blue color of one aluminum, and this is the sp3 hybridized orbital of the other aluminum atom. So this partially filled aluminum sp3 hybridized orbital of aluminum overlap with 3p orbital of the chlorine. So this 1, 2, 3 and 4 similar type of overlaps result in the formation of simple covalent bond. If we see this partially filled sp3 hybridized orbital, it simply overlap with the, if in further explanation, let me explain in detail. Okay. This is the partially filled orbital of aluminum overlap with 3p orbital of chlorine and simple covalent bond is formed, and similarly this chloride form simple covalent bond. So in this state this is Al2Cl6 and in this state this is Al2Cl3. Both are electron deficient in this state. So how it remove its electron deficiency? This lone pair, the orbital which contain this lone pair, it overlaps with vacant sp3 orbital of the aluminum, and this is a bond formed with coordinate covalent nature. Similarly, the orbital contain this lone pair overlaps with the vacant sp3 orbital of aluminum, and this is also a coordinate covalent type bond is formed. So one bond, if we see this bond, this is simple covalent bond and this is a coordinate type covalent bond. If we see the structure, this chlorine is acting as a bridge. Similarly, this chloride is also acting as a bridge. If overall we look at this structure, so there are 4 electrons and 3 centered. So we can say it as 3 centered 4 electron bond, but the nature of both the bonds are different. So what is true 3 center 4 electron bonding? Let's discuss. Okay, 3 centered 4 electron bonds, and few of the example in which this type of bond is present are triiodine, HF2 negative, xenon difluoride, and the carbon which is present in SN2 transition state. So these atoms or compounds or complexes or molecules, they form 3 centered 4 electron bond. Let's start with the transition state which is formed during SN2 reaction. This is primary alkyl halide, and in this compound carbon is present in sp3 hybridized state. So attacking nucleophile attack from the back side and this transition state is formed. In this state carbon is in sp2 hybridized state. Finally this leaving group left this complex and we obtain final product. Okay, if we see this transition state, carbon is sp2 hybridized, and in this state this orbital of the carbon is overlapping with chloride and it contains 2 electrons, and this is called as a simple covalent bond. But when this nucleophile approaches, then the orbital of this nucleophile that overlap with the vacant orbital present on the carbon atom. So this nucleophile donates its lone pair or electron to this overlapped orbital. So In this state, nucleophile, carbon and chloride 3-centered 4-electron type bond is formed. If we see the example of triiodine, this is neutral iodine molecule and iodide attack. Look at this structure. The partially filled orbital of this iodine overlapped with partially filled of this and simple covalent bond is formed. But the coming iodide, it overlaps with the vacant orbital of this iodine, as iodine has many d orbitals in outermost shell. So this is one of its vacant orbital. It overlaps with the attacking iodide, and as a result of this attack, 2 electron and 2 electron are donated by this iodide. So there are 2 electron in this overlapped structure and this is also called as 3-centered 4-electron bond. This type of bonding is also obtained, and that type of bonding can explain symmetric hydrogen bonding. In many of the hydrogen bonded structures, hydrogen is present equidistant from both electronegative elements, and that can be explained only on the basis of 3-centered 4-electron bond. And how this complex or this bond can be explained: 2 fluorides, they commonly overlap with 1 s orbital of hydrogen. So 2 electrons here and 2 electron here. So this is a kind of 3-center 4-electron bond. Question arises that hydrogen has 1 s orbital. So how 1 s orbital accommodate 4 electron? So answer of this question is that fluorine is highly electronegative elements. So due to its electronegative elements, the quantitative measure of the shared electron between hydrogen and fluorine, it can easily be explained on the basis of high electronegativity of the fluorine atom. So on the basis of this concept, we can only explain the symmetric hydrogen bonding. So this is all about 2-centered 3-centered 2-electron bond and 3-centered 4-electron bonding, and how electron deficient molecules remove their deficiency. Thank you very much.